Hello, welcome to exercise 3 of lesson 17. Basically, we're going to build on the previous program we did in exercise 2. What it says here is alter the program that you wrote in exercise 2 so that the output is as follows. The conversion is the same, the space between every fourth item is the same, but notice it doesn't really make sense to say 1 inches, which is what we had before. 1 inches is equal to however many feet. We say 1 inch, 2 inches, 3 inches, and so on. So the number 1 is a very special case where we really don't want to print inches. We want to print inch, right? Everything else we can print inches just fine. So there are many ways to do this, okay? So don't think that there's just one way, but here's the way I did it. This is the code basically as it was in the last section. I'm going to comment a few things out. Let me comment this out. I'm going to comment this out. I'm going to comment this out. So now this code matches exactly what we had before. Let me clear the console here and rerun it and show you that everything is as it was before. We have 1 inches and we have the blank space going on, and that is because the code here now as it sits matches exactly what it did before. But really what we want to do is when we fall through the loop, we want to have a special case. A special case is if inches, the loop counter, happens to be equal to 1, then we want to print out something unique. We want to say that however many inch. In other words, it's going to say 1 inch is equal to however many feet, but only in that case, only in the case that the loop variable inches is equal to 1. In all other cases, we don't want to do that. We want to print however many inches. So the way I'm doing it here is I'm saying if inches is equal to 1, then we're going to print the statement with the word inch there. And if inches is not equal to 1, which is a good example of when you would use not equal, then we're going to print the original statement, which has the word inches printed there. So everything is the same. The loop counter to keep track of our lines, printing out the blank line, all that stuff is the same. It's just that the printing of the statements on the screen are falling inside of these two different if statements here. Notice I don't need a brace here, a curly brace, because there's only one thing to execute after this if, and there's only one thing to execute after this if. So let me go ahead and hit save and run this guy, and let's pull it up and take a look at it. 1 inch is equal to this number, 2 inches, 3 inches, 6 inches, 10 inches, and so on. And so that's a good example. This whole example right here is a really good example of when you would use lots of different things inside of each other. We have a for loop that is contained by this curly brace and closed off actually by this curly brace. Notice this curly brace lines up with the for. Inside we have 1, 2, 3 ifs. One of these ifs has a block because I am doing actually 2 things inside of it. So important type of thing. If you did it a different way, that's okay, no problem. Everybody can do things differently in programming. That's one of the nice things about it. This is the way that occurred to me whenever I did it. Now let me show you one thing that I probably should have showed you in the last section. I told you early on we're converting between inches and feet, so we're taking the inches of the loop variable, which by the way is an integer, right? Notice integer right here, and we're dividing by 12. Now let me show you what happens if I take the dot zero off and just say, okay, take inches, divide by 12. This would be a very common thing to do by anybody writing a program. So let me go ahead and run it and let's see what we get. You get crazy answers. Of course, 4 inches is not equal to 0 feet. 14 inches is not equal to 1 foot. What do you think is going on here? Well, the feet variable is double, which is capable of storing decimals. That's true. But inches is an integer. And when we put a 12 like this with no decimal point or anything, it's treated as an integer. So you have an integer divided by an integer. And since, even though this is a double out here, even though it's capable of storing decimal points, when Java sees an integer divided by an integer, it's going to do the division in terms of an integer. So the result of the right-hand side is an integer. So when you divide, for instance, 7 divided by 12, it's going to totally drop the fractional part. It's just going to be discarded. Only the whole number part is going to be retained, and that's going to be assigned over into the variable feet. So to force it to treat everything to do the actual decimal division, we put a decimal 0 there. There are other ways to do this that we'll talk about later, but one easy way is just to put a decimal there, and that will tell Java, all right, this is still an integer, but this is a floating point number, and so we're going to go ahead and do floating point arithmetic, keep the decimal, and put it over in the result here. So if you ever get weird answers that don't make any sense at all, where it looks like it's truncating something, then go back and look at your code and see if you're doing an operation with 2 integers. You might need to specify that one of them is a decimal in order to force Java to give you what you're after. So make sure you understand this, and then go on to lesson 18, where we will continue working with different data types and learning about how to work with them in Java.